Hello everyone. So today we are going to discuss a problem based on the network analysis. So this problem is related to the concept of nodal analysis. Nodal analysis. So the problem given is find the currents I1 through I4 and the voltage V0 in the circuit of figure 3.5. So this is the circuit given with figure number 3.5. Okay. So now observe this circuit diagram given. So this circuit diagram consists of the branches 10 amperes, 10 ohms resistor, 20 ohms resistor, 30 ohms resistor, 2 ampere current source, 60 ohm resistor. And the number of nodes present in this circuit diagram is, so first of all, when we want to simplify the given network using nodal analysis, first we have to mark the reference node. So at reference node, the voltage is equal to 0. And identify the number of non-reference nodes present in the circuit. See here, this is one node, and this is one, this is one, and this. So at top side of the circuit, all are shorted. All nodes are shorted. So only one non-reference node present in the circuit diagram. Right. So now we apply KCL at non-reference node V0. So apply KCL at node V0. And observe this, the voltage at this node is V0 and the voltage at this node is also V0 and at this node is V0, V0, and finally the currents entering I4 current entering through 60 ohms node is also V0 is the node voltage. So now our objective is to find this node voltage V0 and then find the current I1, I2, I3, I4. Okay. Right. First we apply KCL at node V0. So node KCL, the Kirchhoff's current law says that the sum of currents entering at a particular node is equals to sum of currents leaving at that node. So that sum of In is equal to sum of Iout. So we can write this expression here. So number of currents entering to this V0 node and the number of currents entering from that node that we have to identify and write in this expression. So number of currents entering is only one, that is 10 amperes. So 10 is equal to, so number of current leaving, I1 is leaving current. So we write I1 here plus I2 is leaving current plus I3 is leaving current plus 2 amperes is also leaving current plus finally I4. So these are all leaving currents from the node V0. So here we can note that I1 is equal to, so we can write all the currents in terms of voltage and resistances using Ohm's law. So then I1 becomes, I1 is the current flowing through 10 ohm resistor and node voltage is V0. So using Ohm's law, we can write it as I1 is equal to V0 by 10. And similarly, I2 is equal to the current flowing through 20 ohm resistor. So that is node voltage is V0, V0 divided by resistance value is 20 ohms. And then I3 is equal to current flowing through 30 ohm resistor. So then we can write the expression V0 by 30. And I4 also. I4 is equal to the current flowing through 60 ohm resistor. At this point also node voltage is V0 by 60. So these are the currents in terms of voltage and resistances. So now substitute these all values in equation 1. So then we'll get 10 is equal to I1. I1 is V0 by 10 plus I2. I2 is V0 by 20 plus I3 is V0 by 30 plus 2 plus I4 is V0 by 60. So 10, and at the right side also we have a number 2. So then you can shift to that side. So that becomes 10 minus 2, that gives 8. 8 is equal to V0, we can take it as common. So 1 by 10 plus 1 by 20 plus 1 by 30 plus 1 by 60. So 8 is equal to V0 into, so you can take LCM here. LCM is 60. So 6 plus 20 into 3 plus 30 into 2 plus 60 into 1. So that gives V0 into 6 plus 3, 9, 9 plus 2, 11 plus 1, 12, 12 by 60. So now 8 is equal to V0. So 12 by 60, that gives 1 by 5. 12 ones, 12 5s. So now we can write it as V0 is equal to 8 into 5. So that is equal to 40 volts. So V0 is equal to 40 volts. So then the currents are so I1. So we got the V0 value. So V0 value is 40 volts. Then we have the node voltage 40 volts, and we can calculate the current here. So already we have written the expression for I1, I2, I3, I4. So now use these expressions and calculate I1 and I2. So I1 is equal to V0 by 10. So that V0 value is 40 by 10. So that is equal to 4 amperes. So I1 is equal to 4 amperes. Next, I2 is equal to V0 by 20. So we'll get, we got the V0 value is 40 and divided by 20. So that gives 2 amperes of current. Next, I3 is equal to V0 by 30 is equal to 40 by 30. So that gives 1.333 amperes. And finally, the current I4 is equal to V0 by 60. So that gives 40 by 60 is equal to 2 by 3. That is 0.667 amps. So therefore, the result we obtained here is result. So V0 is equal to 40 volts. I1 is equal to 4 amperes. I2 is equal to 2 amperes. I3 is equal to 1.333 amperes, and I4 is equal to 0.667